Respected ma'am, myself Priyanisha, holding pin number 219555031. I'm studying in stream of Mechanical Engineering at Institute of Aeronautical Engineering. Today my topic name is Classical Definition of Probability. So content, what is classical probability? Formula for classical probability. Example for understanding the formula of classical definition of probability. Limitations, important points, and example. What is classical probability? Classical probability is a simple form of probability that have equal or odd numbers of a something happening. So, simply known as a probability that has equal odds of something happening. For example, rolling a fair die, it is equal likely you rolled you could get a 1, 2, 3, 4, 5 or 6. Selecting bingo balls, each numbered ball has an unequal chance of being chosen. So, formula for classical probability. The probability of simple event happening in this number of times the event can happen divided by the number of possible events. So here is a formula: P of A equal to N of A by N of S. So real equal to P of A equal to probability and N of A equal to number of favorable comes and N of S equal to number of all possible outcomes. So P of A means probability of event A. Event A, whatever event you are looking for, like winning the lottery. N of A means number of possible outcomes for the event A. N of S equal to number of all possible outcomes of the experiment. Here S is stand of sample space, which is the set of contents of all possible outcomes of the random experiment. So here is a formula of classical probability. Once again I'm going to repeat: P of A equal to N of A by N of S. N equal to number of favorable comes and N of S equal to number of possible outcomes. Probability equal to number of favorable comes by number of all possible outcomes. P of A equal to probability of event A. Number of favorable comes equal to mean number of possible outcomes for the event. So example for understanding the formula of classical definition for probability. A coin is tossed once, is equal to head and tail and n of is equal to 2. Let A be the event of getting a head, A equal to head and n equal to n of A equal to 1. Then P of A equal to n of A by n of S. N of A equal to number of favorable outcomes. N of S equal to number of favorable possible outcomes. So therefore N of A, P of A equal to probability equal to 1 by 2. Limitations. For this definition of probability, we are indebted to a Bernoulli's and a Laplace. This definition is also termed as a pure definition because the probability of event A is defined as a basic prior knowledge The classical definition of probability has the following demerits or limitations. First one, equal to, it is applicable only when the total number of events is finite. So the total number of events should have to finite. Second one, it can be used only when the event are equal likely or equal probable. This assumption is made well before the experiment is performed. This definition has only a limited field of application, like a coin tossing, die throwing, drawing cards, etc., where the possible events are known well in the advance. In the field of uncertainty, or where no prior knowledge is provided, this definition is inapplicable. Important point. A. A. The probability of an event lies between 0 and 1. Both includes that 0 greater than or equal to P of A equal to greater than 1. When P of A equal to 0, A is known as to be an impossible event, and when P of A equal to 1, A is known as to be sure event. B. None occurrence of event A is denoted by A, and it is known as complementary event of A. The event A along with the complementary A form is a set of mutual exclusive and exhaustive events, that is P of A plus P of A, P of double dash P equal to A of plus P of A equal to 1 double dash, P of A equal to 1 minus P of A. Important points. C. The ratio of number of favorable events to the number of unfavorable events is known as odd favorable of the event A, and its inverse ratio is known as odd against the event A. Let M be the number of all possible outcomes of a random experiment, and MA be the number of favorable outcomes of the event A. When odd is favorable of A, MA, and M equal M minus MA. Odd against A equal to M minus MA. Therefore, the odd in favorable of A and odd against A are the two ratios which inverse to the each hence. Odd is favorable of A, x odd against A equal to 1. Examples. Question: a coin is tossed 3 times. What is the probability of getting 2 heads? At least 2 heads. Answer: when a coin is tossed 3 times, first we need to enumerate all the elementary events. This can be done using tree diagram as shown in below. Start. Okay. Head divided to head and tail, and head tail. Okay, hence the elementary events are the head and head tail, head tail 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 head tail head tail. That is equal to what we are assuming. Thus the number of elements events n of s equal to 8. So we got 8 elements in the elementary. two two heads. Outcomes of this outcomes two heads occurs in the three cases, namely head head tail tail head and tail head head. If we denote the occurrence of two heads by the event A, and if assume that the coins as well as performer of the experiment is unbiased, then this assumption implies that all the eight elementary events are equally likely. Then by the classical definition of probability, we have P of A equal to N of A by N of is equal to P of A equal to 3 by 8. P of A equal to 0.375 or 0. Or 35.37.5% for at least two heads. The P of B equal to here the sum, and the P of B equal to 0.50 or 50%. Thank you.